Good morning. Today we are going to analyze geometric sequences and series. We are going to be able to find the general term in the sum of a finite and infinite geometric series. We looked at arithmetic sequences on the last section, in which we dealt with a linear equation in which the difference was constant. So the slope throughout the whole sequence was the same. In this lesson, we are going to be looking at geometric sequences. And in geometric sequences, we have a ratio in which remains constant throughout the whole sequence. The ratio we're going to denote it by the letter R. Now, when we are looking at a geometric sequence, we are going to be looking at an exponential growth or an exponential decay that ties very nicely to chapter 7 on exponential functions. But let's go and look at example number 1. On example number 1, we need to be able to decide if the infinite geometric sequence or the infinite sequence is arithmetic, geometric, or neither. Remember, arithmetic, that means that the difference has to be the same throughout. And if you guys notice, 4, 16, 32, you should be able to tell right away whether it's an arithmetic sequence or not. In this case, -4, -1, 3, the difference is the same. You notice on letter C, the difference is not the same, so it's not arithmetic. And in here, the difference is 1/3, then 2/3, and then to the next one is 4/3, so it's not the same. But we need to be able to go through the process and analyze each of them carefully, even though you are able to do it quickly on your head. Let's analyze the first one. Let's see if it's arithmetic. To decide if it's arithmetic, we need to be able to find the difference. So we're going to take the second number minus the first number. -8 minus 4 is -12. Then we're going to take the third number minus the second number. So 16, we're going to subtract the second number, which is -8. Negative and negative is a positive, so 16 plus 8 is 24. If you notice, the difference is not the same, it's not constant, so this is not an arithmetic sequence. Let's check and see if it's geometric. To decide if it's geometric, we need to be able to find the ratio. And what I mean by the ratio, they're going to take the second number divided by the first number. So we're going to take -8 divided by the first number, which is 4. This is -2. Then we're going to take the third number divided by the second number. The third number divided by the second number, 16 divided by -8 is -2. Then we're going to take the fourth number divided by the third number, so we have -32 divided by 16, and that'll give us -2 as well. So if you notice, the difference is the same throughout, it's constant. So in this case, this sequence is geometric. Let's try letter B. First, we need to be able to determine if it's arithmetic. To determine if it's arithmetic, we're going to take the difference. We're going to take the second number minus the first number. Negative and negative is positive, so -4 plus 4 is +3. Then we're going to take the third number minus the first number, the second number. So the third number minus the second number. Negative and negative is a positive, so 2 plus 1 is 3. Last, we're going to take the fourth number minus the third number. So it'll be 5 minus 2 is equal to 3. Notice that the difference is exactly the same throughout. So this is a arithmetic sequence. Now let's look at example number letter C. First, find out if it's arithmetic or geometric. Go and try it yourself, pause it, and then we can check our answers. So try letter C by yourself. Pause it. Great. So let's find out if it's arithmetic. To find out if it's arithmetic, we're going to take the difference of the second one minus the first one. So 9 minus 3 is equal to 6. Then we're going to take the third one minus the second one. So negative 27 minus 9, and that'll give me negative 36. Notice that the difference is not constant, it's not the same. So in this case, this is not an arithmetic sequence, so no. Now let's check and see if it's geometric. Geometric, we're going to take the ratio. So 9, the second one, divided by the first one, that is 3. We're going to take the third one, divided by the second one, that is negative 3. The ratio is not the same, so this is not a geometric sequence, so it's neither. And let's try the last one, letter D. Let's check and see if it's arithmetic. We're going to take the difference. We're going to take 2/3, second fraction, minus the first one. That will give me 1/3. Then we're going to take the third one, which is 4/3, minus the second one. Same denominator, so 4 minus 2 is 2. So the difference is not the same, so it's no. Now we need to check and see if it's geometric. If it's geometric, we need to be able to take the second fraction divided by the first one. That will be 2/3 divided by 1/3. To change my division to multiplication, I'm going to keep the first fraction the same. I'm going to change to multiplication. I'm going to take the reciprocal of the second fraction. The 3's cancel, so it gives me 2. I'm going to take the ratio of the third one divided by the second one. I'm going to take the third one, and let me change it to multiplication. I'm going to multiply by the second one, so I'm going to take the reciprocal, so it'll be 3/2. The 3's cancel, so it gives me 4/2, which is 2. And let's do the last one. We're going to take the fourth fraction divided by the third. That'll be 8/3. And I'm going to take the reciprocal, so that'll be 3/4. The 3's cancel, and that'll give me 2. So if you notice, the ratio remains the same. So this is geometric as well. When they're asking you to find the n term, remember the rule for the n term, if they're asking you to find the n term, they're asking you to find the equation. So they want you to find the equation so we can find any term on the sequence. We are dealing with a geometric sequence. And the first term is a sub 1. The common ratio is r. So a sub 1 is the first term. And r is the ratio. Let's look at example number 2. It says, write a rule for the n term. If they're asking you to find the n term, they ask you to find the equation. They ask you to find the equation for this infinite sequence that you are able to find any term on the sequence using the equation. To find the equation or the n term, we need to be able to use this formula. A sub 1 is equal to a sub n is equal to a sub 1 multiplied by the ratio to the power of n minus 1. and I need to plug in the values of a sub n, a sub 1 and r. So I need to find a sub 1 and r. If you guys remember, a sub 1 means the first term, which is 5. R is the ratio. They don't give me the ratio, so I need to be able to find the ratio. Find R. To find R, we are going to take the second number divided by the first number. So we're going to take the second term divided by the first term. 2 divided by 5. We can simplify, and we're just going to leave it as a fraction. Now that we found it, we can just plug it in. That'll be 2 over 5 to the power of n minus 1. And this will be your final equation. Now remember that you are not able to simplify it, because if you have 2 times 3 to the second power, the square belongs only to the 3. In this case, the n minus 1 is only an exponent for the 2/5. You cannot multiply 2 times 3 and then to the second power. So in this case, we can now multiply 5 times 5 over 2. And many of you guys are going to simplify on the test, which will be incorrect. Now, does this equation look familiar? Just like I mentioned before, this is an exponential function. So you have y is equal to, do you guys remember problems like this before? 2/5 x minus 1 plus 3. When this was your h and k. Now, is this an exponential growth or decay? This is 2/5, which is less than 1, so this will be an exponential decay. So your graph will look something like this. And this will be your x and y axis. So whenever we're dealing with a geometric, we're looking at exponential growth and exponential decay.